All right, in the last video we were looking at the image thingy, how we can create our own images. So to create an image, so you can make any type an image by just implementing these methods, right? Color, model, bounce, and add. If you implement this method, basically your type returns an image or something. So we got three methods, right? Let's see what it does. Color model. I don't know, like seems like what sort of model it's using, what sort of color model it's using. RGBA model. Seems like color model can return different types of color models. For now, we are using RGBA model. This is already an implementation. Like we are not implementing. Go already provides one. So RGBA, I believe R for red, G green, B blue, A alpha channel. And bounce. Bounce tells us the size of the image, the height and width. So this is the top, the left and right, X and Y for the top, where the image starts. Like so basically this is the top left point, and this 2 points is the bottom bottom right point of the rectangle, right? So essentially this tells us the rectangle is 256, as this height and width, I think. So basically, yeah. And at, so this tells us at every time when we ask for pixel value at these places. So what's the pixel value for the position 0, 0? So this is what returns those values. Currently we are using some sort of like goofy ass function that kind of returns some like weird looking number. Also we are using unsigned integer 8. So this returns value between 0 and 250 255. So yeah, that's gonna work perfectly for RGBA. This is some sort of like XOR operation or something. I don't know what it does, but we're just gonna like we don't need to know what it's doing because I'm not gonna use this image anyway. So yeah, so this creates some goofy looking image, and pick so image so we create an image, and so image takes let's see, let me just print what do we get. All right, why the hell is the terminal like I need to get this to the bottom sheet. Where is the dock operation option views? Okay, cool. Now we can just say go run. What do we get? So we have a empty thingy. Let me just quickly ask Google like What does it mean? ChatGPT, I mean. Why is M here? It's creating a value of type image. Your image type is defined as image struct. Struct is a collection of fields, the fields inside it, but your struct has no fields. It's an empty struct. Okay, create an instance means create an instance of image with no fields to initialize. Y prints empty braces is an empty struct value because, okay. So structs value with their content inside braces. So when we print a struct, it just prints the values. Okay, cool. Why use an empty struct? Methods belong to types, not just data. You attach method to image, so we can only attach methods to types. Another question I have is pixel image. What is this doing? What does this do? From Go tour package, it takes anything that implements the image interface and displays it in the Go tour web page. Under the hood, its parameter is basically show image, takes a image type, and image interface is okay. This is the interface, we implemented it. Your image type has all three methods, so yep, this can act like an image. And what happens? So image asks for calls, okay. Your code computes, returns, so in your case, then pixel binary. For pixel 1020, so we are looking at how binary XOR works. Give some numbers, say 30. What the hell? You didn't say how, bro. It does not save a PNG, so it's just weird for the usually it's just still did not understand. So pick show image. What does it return? What does it return? Returns nothing. Is function basically nothing, no return type. So return you would see, but there's nothing. So this just does an action, displays the image. Okay, it says it displays an image, but I don't see it, bro. Okay. Outputs this. That makes sense. Behaves differently depending on where it runs. In the Go tour playground, it doesn't literally drop pixel to your terminal. Instead, it outputs a special encoded message like that is image marker saying this is image data. As we're doing call your image. Okay, so this package we are using Golang X2 pick only works like it behaves expect how it's supposed to behave in the website, but not here. So this is essentially a base 64 encoded string. we can convert this into byte and just convert it into PNG. To do that, we need to use PowerShell. I'm gonna show you how to do that in the PowerShell. Let's see. All right. So first we need to copy the text to a text file, a TXT file. So I have copied it. Shit, my bad. I've copied it into the images.txt file, and next, so we just need to call this function system IO file write all bytes, which takes a path, and this is the so essentially this function call or whatever converts our base 64 string to bytes basically, and then it writes that bytes into this path. All right, first create the path, join path, get a location. So this is some get location gives us the string, and join path takes two strings and joins it. So yeah, like if I call path, I should have like this golang temp output png, and now we can just call write all bytes. Okay. Again, this is a C# methods or something. This is how you call C# methods, bro, in PowerShell. System IO file write all bytes and takes a path and convert it. System convert from base 64 string. Oh shit. Okay, we can use the get content. Get content. We're running out of space, bro. Get content. So we are in the image text and should work, but we are getting some error. Like, what is going on? Get content. Okay, we can wrap this. Does it work? Oh shit. All right, we somehow made it. Anyway, I already had like output PNG, so I'm gonna just remove it. Remove item output PNG. Okay, let's run this again. All right, we got the PNG. So this is how it looks like. So essentially we just we converted this base64 string to bytes and then write those bytes to a destination basically. So we got this goofy ass numbers, right? Instead of this, let me just use 255 and run it, and then whoa, look at this. I think it has some repetition or something. I'm seeing some repetition. Just notepad image txt, save it, and let's run this again, and invoke. Yep, we got a white image. So every pixel has like every like bits like RGB, all these values are turned all the way. When RGB has max values, it will be white. We can create the dark dark value by setting it to 0 essentially. So I'll keep the alpha channel max because we don't want it to be transparent. All right, cool. What do we do with this knowledge, bro? I don't know. That's why I don't like this. I don't like this exercise. Not really useful. So yeah, we reached the... Is this the end of the image thingy? All right, it looks like we reached the end of images. The only things left is generics and concurrency. I know what generics are and concurrency is, right? Generics, well, it's just a way to sort of like instead of like making like instead of statically typing like if you have a function that takes like concrete some sort of like when you write a function, when you create a function, you give it a type, right? You expect this parameter to have this type, but instead of hard coding a type, you can let it the color decide its type. That's basically generics, right? So let's say you have a function that creates an array. Let's say it creates a slice or something, and it takes the slice as input, and you don't know the type of the slice, so you let the color create the type instead. So yeah, let's see. Seems pretty like a pretty small section. Let's get it over with. Go functions can be written to work on multiple types using type parameters. Holy shit, this syntax is kind of cursed, bro. The type parameters of a function appear between brackets before the function's arguments. What is going on? The type parameters of a function appear between brackets before the function's argument. Brackets. Okay, all right. We got a function keyword and the function name. We got a bracket, and here we have a t comparable. What is that? And this is the argument. Yeah, bro, like t, and x is t. So comparable is this some sort of like a keyword? This declaration means that S is a slice of any type T, right? That fulfills the built-in constraint comparable. It's a constraint. Like it constrains the type. Like in other programming languages, we can constrain types. So we can say that this type can only be subtype of a string or something. It can be like a integer. It needs to be positive integer. Like, I don't know, dude. Like, it can't be null or something. We can use constraint. X is also a value of the same type. And what is this? Comparable. X is also a value. Comparable is a useful constraint that makes it possible to use the this comparison operator and not equals to operators on values of the type. In this example, we use it to compare a value to all slice elements until a match is found. This index function works for any type that supports a comparison. Okay, let's look at it. Index returns the index of x in S or -1 if not found. Func index. All right, so we get a T. This is a generic comparable. Yes, and the T is used as type for the slice, and it's also used for the X. So the type T is used in two places and returns int. Okay, so for I, V, range. So range S returns index and value. V and X are type T, okay, which has the comparable constraint. So we can use a comparison equal. What is this? Equal comparison is equal comparison. If V is equal to X, return I, returns the index. If not, returns a negative, non-negative. Okay, it's a negative number anyway. Index works on a slice of ints. So we got a slice of int which contains 4 elements. Okay, 10, 20, 15, negative 10, SI, C, what the hell? FMT, println, index SI 15. So we are passing slice of int as a type, so works. And this, so they're both type of int, so it works. Here it works. So now it's gonna like swap wherever the T is used. with these types, and just gonna check if we got a value, right? Value is gonna be like integer. If v is equal to x, then returns I. So what is this index? It returns the index. Index. So range returns, like there's only one like return. I'm assuming it's just gonna like exit the function because we're just returning it. And strings, so this will also work. I'm just gonna copy this, and pretty simple stuff. So I'm assuming it's just need to return like 0, right? The first one's gonna match. Like, what is going on here? Like, go run. Okay, returns the index 2. Okay. So index, I guess like it takes the 15 and returns the matching index. So that's why they're looping. They're trying to find where this value, the value's position in the slice or array or whatever. Goofy. So here it doesn't exist. So it's going to return -1. So essentially, dude, this is JavaScript's find function. You know what? Let me just quickly create that. All right, so const. Let's see. List. We got a list of 1, 2, 3, 4, and list find 2. Let's see. So we should get 1 because that's the index. Console log node sheet. What's going on? Number 2 is not a function. Oh shit. String is not a function. What the hell am I supposed to do? Okay, maybe we need to use the find index method, right? Jesus, what is going on, dude? String2 is not a function. Okay, seems to take a callback. Why? Well, let me just ask ChatGPT, what is the correct method here, bro? What's the JS method that finds the index of element? You're super close. Callback function. If you just want the index, use index of 2, 1. Find exact value. Find index. Find by condition. Jesus Christ, man. Okay, so the point is JavaScript as a built-in method. We don't need to create our own method, bro. So essentially what we did is just create a JavaScript equivalent of method. So this, I mean, like, we could create a struct and create a method on that struct. Like, if you're crazy, dude, you would do that on the string type. right? I mean array. That would make it seem like it's just it's like a JavaScript, but no. All right, let's see. Let's go. So what's going on? So the point is not the logic to implement finding index of element in a slice. It's just like we can just swap it right here. This index method works even when we pass a type of integer, a type of string. We're not like hard coding that values in the function declaration. So that's the point of generics. Generic types, in addition to generic functions, Go also supports generic types. I mean, we looked at functions, generic types. What is this? A type can be parameterized with a type parameter, which could be useful for implementing generic data structures. This example demonstrates a simple type declaration for a singly linked list holding any type of value. As an exercise, add some functionality to this list implementation. List represents a singly linked list that holds values of any type. Are you crazy, bro? Type list takes like this is the generic thingy. So we have a type list takes anything, and next, when we call next, it returns so what is this? This is a pointer, like pointer type, right? Next is a pointer type dot pointer type. What is a pointer type? So a pointer type holds addresses, right? So next holds address and returns, it's not returning anything, it's just holding two like fields, next and val. Well, let's just copy. So what are they trying to all right. Honestly, I have no idea, bro. So add how make this work, adding functionalities. Generic singly linked list. Now you need methods to actually do stuff, list stuff. Typical linked list operation to add in order. Create a node, new list, append, prepend, traverse, find, delete, length. Okay, create first node, function, new list. Okay, new list, what is this? Takes a generic any, so it's not taking comparable. And here, oh, any, like we said, interface braces is equal to any, bro. We can use that, use any instead of that. So it has only one parameter, val, which is a type t, generic t, and returns a list, pointer to the list. And also it's gonna use the generic here. What is this syntax, bro? Like, what is this syntax? We got a type, and inside of that we have a value, like we have a type, how, why. I don't understand this syntax, bro. Okay, let me just ask ChatGPT. What is this? What is this? This is Go generics, pointer stacked together, looks cursed. Break it apart. List T. Okay, list T. Okay. What the? Okay, we defined it. Okay. We defined that type. So means a list where t is int. Generic, bro, this is a generic. So looking back, like here, right, list t, so this basically becomes a type. Okay, equivalent string means okay, we got that. So this returns a pointer to this type pointer basically. So that's why like this gives me the address of list. This is the type, and here I am passing a val new list. So if I call new list, this new list will take a val parameter argument. I need to pass like let's just read through it. Add to end, append, current, what is this? Okay, L is the whole the address of the list, and basically L gives us the address. Current, so we get the current. Next, if next is not nil, current plus current is equal to current. Current, we are assigning current next to current, and the what is this, bro? Prepend, print all values, print print. So printf length find. Okay, so we are just manually implementing some stuff. This is not really like useful. You're not supposed to be learning this stuff, bro. Like this is some advanced low level stuff. Right, let's just comment out this for now, and fmt print ln list. What do we got? So we got a list. So this is a field, right? We don't have a next value, so that's why it's a nil. What if we have like two values? Okay, new list. The only way to add another value would be to appending it, bro. So list append to. So the next value is the address of the next value in the memory. So let's look at the new list again. How is this being created? So it takes a value of type t and returns a list of so this is basically like a struct. I think it's basically like a JavaScript object, but we can do some more stuff with it. So I'm just gonna assume it's an object. So we are returning, so type t. Again, we're just just declaring, or like we're saying basically we're gonna use the t generic, and like when we use the actual type, For example, here we're using integer. We're gonna replace the t with wherever with that initial like value we used for initializing it. So val becomes integer type, list becomes integer type, and this list. So essentially we looks like this. So we are creating a list. So we are initializing a list with val this, and we are returning the address. So we are returning the address. Why not the list? So we can modify it, I guess. Next, let's look at append. Append, what is this syntax? L, I mean, if you look at it, it's got to be a method, right? It's got to be a method. So we have a L. So let me just, is this a method? I don't understand. That's a method. This syntax weird at first because that's part before. Okay, receiver. Wait a minute. So this is a function. This is the receiver. This is a pointer receiver. But why do I have L? This method belongs to this type. Okay. I know, bro. Like, why use a variable L? Because L is just the name of the receiver variable. L is basically a parameter, same as function. It gives a way to refer to the object inside the method. Okay. So we are kind of creating a variable so that we can call values inside of it. So since it's a struct, we can access its field. So L, where is it? Where are we using its field? Yeah, we assign it to a current variable, and current, so basically is we are checking if L exists. Oh, wait a minute, wrong thingy. So we are basically checking if the next exists. If next doesn't exist, then we essentially create what are we like, we're just modifying the underlying struct and adding a next. So current next, what is this current next? Current next, not nil. Wait a minute. So not nil means there's already a value. There's already another value, right? If it's nil, there's no value. So there's a second value if there is a nil, there is non-nil. Current next. What is this assignment, bro? Like, I don't. So basically, right? So anyway, the last element is gonna be set to next. I think it's much easier if I just show you or something like. So if I want to like this, 2 is next, and then we set current to basically 2, and then when we append it, next will be whatever value we appended, basically. So that's what they are doing. So they are creating, I mean, they are like, are we current next? They're creating another list, another new instance of a list with value why? I thought like, why does it next value, next field hold the outer type? Can it not hold just the element? Okay, I don't know, dude. These concepts don't store file, they store whole nodes. Next means each node looks like this, bro. Next does not mean next value, it means pointer to the next node. So when you do, you are making a new node and storing its address. Why not just next t? Suppose you did type val t, then a node would be val 5 next 5. Okay, so this is what I meant basically. But now where is the next node? How do you continue to the node after 10? How do you know if list ends? Shit, man. I think I'm gonna quit this garbage because this is like a low level, like when you're learning data structures and shit like that. That's where you use this, learn this. Great, we finished it. We finished it. Okay, next, I got some stuff to do. Right. Okay, before we jump into the last section, concurrency, I want to learn more about file handling in using Go. So basically, I want to replace my Python script with Go. So I want to learn how to do all this stuff. Basic file creation and writing. I want to create a text file, write to it, append to an existing file, overwrite file contents, close files, and I want to work with JSON. I want to read the JSON as bytes. I don't know, dude. Convert bytes to string, read file line by line, read large files in chunks and buffers. Okay, this is pretty cool, man. Like we don't want to dump the large JSON into the memory. We want to read it by chunks and process those chunks. Check if file exists before reading. Great. Okay, working with JSON. Create Go struct for JSON. Convert Go object to JSON. Write JSON to file. Read JSON file. Parse JSON back to Go struct. Preprint JSON. Handle optional missing JSON field. File metadata. Okay, check if file exists. So this is, we want to check if the file exists in our computer. Get the file size, get file name, file extension, modified time, check if path is file or directory. That's gonna be cool. List everything in directory. List only directory. List only files. Recursive directory walking. Ignore certain directories. Filters file by extension. Path handling. So this is gonna be cool. Join paths safely. Because Windows and Linux, their path is different. Get current working directory. Get absolute path. Extract file name from path. Extract extension. Get parent directory. Normalize paths for Windows and Linux. This is gonna be crazy, bro. This is important. If you screw this up, screw the file name or path, I don't know, dude. Like, I once created a file name that had colon and the file, I could not even find the file. It's in the back rooms or something. Copy, move, delete. Copy file, rename file, move file, delete directories, create nested directories. Binary data. Read image video as raw bytes, write raw bytes to file, stream data from buffer to file, copy bytes from HTTP, response to file, save memory buffer to disk, work with bytes buffer. Create temp file, create temp directory, auto cleanup, permissions, set file permission, read permission, make executable file. Bunch of shit ton of. We are gonna go through them one by one.